All right, welcome everyone. This is the final installment of our College of Forestry and Conservation's Fall Seminar Series. And today our guest is Dr. Kevin O'Hara. And he actually was a faculty member here for 8 years. And after that he moved on to Cal, to UC Berkeley. And he's been there for 16 years now. He teaches silviculture and applied forest ecology at Berkeley, and he recently came out with a book, and it's titled Multiaged Silviculture: Managing for Complex Forest Stand Structures. So after Kevin talks, you guys can go out and buy that book online, and he'll be talking to us about silviculture today, and it's titled Uneven Age Silviculture: Debunking Old Myths and Developing Strategies for Moving Forward. So welcome Kevin O'Hara, and he'll give us some direction.
Thanks. Oh, thank you. So I was a faculty member here in 1990, or beginning of 1990, and in the spring of 1990 I came here and interviewed for this job. And at that time I basically outlined the direction of what I said I could do for research. And it's basically what I'm going to describe here today. But that was 24 years ago, or 25 growing seasons. So it's 25 years in silviculture time that I was here and I outlined that plan. And I basically stuck with it, and it's still a large part of what I do in research. So my message here is that for those of you who are young researchers or young researcher wannabes, some of these decisions that you make really early in your career stick with you. They end up being lasting research projects, and that's a really good thing, I think. And I think that it's a really important lesson to remember. And the corollary to that is that these research careers go by really, really fast. And so next thing you know, you've been doing it for 25 years or so. So my title is about uneven age silviculture, debunking old myths and developing strategies for moving forward. So it's going to be both myth and then some ideas on what we might do to make things a little bit better. So my first slide there, it's about names, and I've got a bunch of names that have been used to describe uneven age silviculture in various forms. A lot of these come from Europe, but what you'll notice here is that a lot of these have a ecological basis to them: ecoforestry, back to nature, ecological silviculture, so forth. Some attempt to describe the intent of the silviculture. So they might be restoration forestry or retention forestry, sustainable forestry, something like that. But we have all of these names, and all of these names generally try to describe approaches that are soft, or maybe they feel good. But a lot of them revolve around uneven age silviculture. But the term I like to use, and the term that I've used to title that book that Justin just described, is multi-age silviculture, because I think it's more inclusive, and I think it removes some of the baggage that's associated with these myths that I'm going to talk about in my seminar today. So I'm going to go right to these myths, and the first one is that uneven age stands must have reverse J diameter distributions, and a related assumption is that all age classes should be represented or should be included. And so what you see here is this classical reverse J-shaped diameter distribution curve with number of trees and tree diameter class. This is so ingrained in uneven age silviculture that it's often used as diagnostic. In other words, somebody looks at a diameter distribution, and if it resembles this shape, it's automatically labeled uneven aged. And notice that I haven't said anything about the ages of these trees. This is based just purely on sizes. This is a paper that a guy by the name of H. Arthur Meyer published in 1952. And Meyer was a Swiss immigrant who came to the United States. He landed at Pennsylvania, what was called Pennsylvania State College at that time. And he basically measured the diameter distributions, not of stands, but of whole forests. And these forests, he found, had diameter distributions that in various ways followed a reverse J-shaped curve. And so what we've got here is we've got one from Pennsylvania, B is from Switzerland, we've got a New Hampshire, and another one from Mississippi. So he went to a variety of different places, and when he expanded his scale, when he went beyond the individual stand to many stands, what he found was he found this distribution. So it doesn't say anything about the ages of the trees. He considered virgin stands to be balanced, and I'm going to pick on the word balanced here a little bit too, because they have been maintained for long periods of time by natural processes of growth and mortality. So he took those diameter distributions and he said, well, they're balanced, implying that they're stable because supposedly they'd been maintained for a really long period of time. He promoted using forests of an entire county or state to determine the appropriate balanced diameter distribution. In other words, you didn't want to look at the stand as your model. You wanted to take many stands and average them. So we use this thing called the Q factor, which is just the quotient of number of trees, one diameter class to the next. I won't go into details here, but it's what gives us this consistent diameter distribution, which we also call negative exponential. These are diameter distributions from northern hardwood stands in North America. And what they are is different curves. So this is a stand called Bergland. And what you see is a whole bunch of different curves that are based on the size of the area that was included in the measurement. And so that starts off at 0.05 hectare and ends up at 3.2. And in this case, you see the curves are all pretty consistent. Here's one called Dukes, and you see kind of changes form as you go to larger plot sizes. And you see the same thing in this one here at Isle Royal. And the point I want to make here is that none of these really fit that traditional model of a reverse J-shaped diameter distribution, but it also demonstrates the importance of scale, and that when you look at these things in different scales, you're going to get different results. Okay? So when Meyer was looking at stands at the county level, it's no wonder that he ended up with a particular distribution that resembled that reverse J, particularly since he really wasn't even looking at age structure. He was averaging even age stands of different ages. So we have very little stand level data to support the reverse J. We know that diameter distributions are highly variable. Within stands, it varies with age, scale, and disturbance history. And what this leads me to conclude is that these diameter distributions, and using them as the model for unaged silviculture, is not an ecological concept. It's a human construct that we've made. And that leads to my second myth, and that's this idea of the balanced stand, which I've also already talked about a little bit. This is Meyer, the same guy that immigrated from Switzerland, and he basically developed this diagram. Well, actually, he didn't develop it. You can find it earlier in Europe, but it's basically a triangle with large timber, medium timber, and small timber on the three sides. And he graphed the development of a Swiss stand here, and you see it's right in the center, and then a stand from the US, and you see it's kind of veering off. And he concluded that, well, ideally you'd have equal amounts of all three of these types of trees, large, medium, and small saw timber or timber. And so he said, that's the balanced stand, the one from Switzerland, but the stand from the United States is not really balanced because it's veering off. It's getting too many large trees. Imagine that. How often do we not want a stand with large trees in it? So the balanced stand is defined, it was also defined as a point where current growth could be annually or periodically removed without changing the structure or the initial volume of the stand. That's sort of traditional forest management. A third definition of balanced stand comes from the Hawley and Smith silviculture textbooks. This is the most recent one, and it's just simply that each age class in an uneven age stand should occupy equal area. And so what you see here depicted are 15-year-old trees that occupy the same amount of space as this 190-year-old tree, or these 5 45-year-old trees, or these 3 60-year-old trees. And so what that means is that those many 15-year-old trees are going to reduce in density down as they age, from 15 to 30 to 45 to 60 to 75 to 90. And they'll end up being just one tree occupying all that space in the end. In other words, that's how you explain that you might need a reverse J diameter distribution, because you have to have a lot of little trees to fit on that same space as one big tree. But again, there's really no ecological basis for this. So this form of balance is analogous to area control forest regulation. For those of you who've had a forest management class, each age class occupies equal area. This miniature even-aged forest model allowed for estimation of growth and stocking relationships using even-aged growth and yield. And so if you think about it, I mean, just imagine that you're back in the primitive era of forestry, which is probably 80 or 100 years ago, not that long ago, but you are grasping for ways to manage stands with this concept, well, maybe I can manage more than one age class at a given time. Well, logically, they turned to some of the information that was available for even-age stands, including yield table relationships and forest regulation, and they thought, well, let's just apply that at the stand level. And that's what this is. Meyer's the one that promoted the Q factor first, and basically is the one that said that's balanced. And so what you see here is a stand with a nice smooth curve here, the solid line. That follows a negative exponential, or reverse J, or a Q factor. And then you see a stand that's grown, represented by the dashed line here. And so what this means is that this is your balanced stand, and that anything else is imbalanced. I mean, that's one of the implications of using a term like that. But then periodically you'd move the stand back to the balanced conditions. And you supposedly repeat that on and onward. I just threw this one in here. I didn't take this picture. I stole it off the internet. And I'll explain why to you. But the third myth is that uneven-age silviculture is synonymous with high grading. And what I mean by high grading, for those of you who aren't familiar, is this removal of the best trees in the stand, which has economic implications, it has utilization implications, but it also has genetic implications. In other words, it implies that it's a dysgenic practice. And I don't know how many times when I was a faculty member here at the University of Montana that I heard people, I'm not going to point any fingers here, but local people who would make the analogy that uneven-age silviculture is like having a horse race and then taking your last place finishers and putting them out to stud. Do you remember that, Bev? Oh, okay, I won't tell you who it was. So I put a horse picture in here. This is a shelterwood stand. This is actually a mixed oak stand in Croatia. That's the shelterwood overstory. And what I want you to look at is it's a beautiful stand, but notice the number of mature trees in that stand. Here's a seed tree stand. This is from North Carolina. Those are loblolly pine trees, and you notice that there's a smaller number of overstory trees there. And the point I'd like to make is that when we do uneven-age silviculture, the idea is that we're going to have a generation of trees that's oldest and largest, and then we're going to have lower canopy strata that are going to be younger, and there may be 2 of those, or 3, or 5. I don't think we need to get too high in terms of numbers. But the point I'm trying to make is that when we looked at those age classes, each one of those age classes, or each stratum, is essentially breeding with itself. And the number of trees in that stratum, then, needs to be sufficient that you're not going to have a lot of inbreeding pressure, that you're going to have enough variability. But when you compare what we do with even-age silviculture treatments like seed tree and shelterwood, I don't believe that uneven-age silviculture has any fewer breeding level trees than those even-age systems. And here's just a diagram of an uneven-age stand, and I put these arrows on here to imply that what you have is you have these trees that are interbreeding. You have possibly some interbreeding with this next oldest age class, depending upon the sexual maturity of these trees. But that each cutting cycle, you replace those older trees, and you have another generation of trees that may or may not be related to the older one that was removed. And so what you have with uneven-age silviculture is this rotating cycle of breeding age trees that occurs over and over again. I would argue that you have more genetic diversity and less potential for dysgenic selection with an uneven age system than you do with some of our even age systems. So my myth number 4 is that uneven aged equals all aged. And this is I even heard this recently in the SAF convention in Salt Lake City. And the idea here is that not only do you have tree diameter here, but each diameter class represents an age class. Here's a real Ponderosa pine stand with 4 age classes. This is the diameter distribution, and you see it's not reverse J. It's not even very smooth. And when we actually looked at the ages of these trees, what we found was that there were 4 age classes here, and that they kind of blended together. They weren't necessarily distinct in terms of their diameter, but they were there. And rather than being all aged, what we had is a 4-age stand, and what we have is the result of disturbances that create the event, create the circumstances that allow an age class to germinate and start to grow. And in this case, that happened 4 times during that sequence. So, importance of understanding age structure in uneven age silviculture, it's really important. This is a mixed species stand that you have in this region here. It's got western larch and lodgepole pine over grand fir and Douglas fir. And a lot of people will look at this and say, well, look at that grand fir and that Douglas fir coming in there. They're obviously moving up through the canopy and are going to take over. Some people would call that a climax, a grand fir climax, and they're going to take over the site. And instead, what we find when we actually look at the age structure and the development of those trees, it's not the grand fir taking over the larch and the lodgepole pine. They all started at the same time, and the Doug fir and the grand fir got outgrown. So what you see here is a reconstruction of these trees. They all started after a fire about 1890, and we get the stratification pattern. And the point I'd like to make about age is that if we ignore age, we're essentially practicing uneven-sized silviculture. I think it's dangerous because what is uneven size? Aren't all stands uneven sized? And I think that may lead to dysgenic selection. If we take that lodgepole mixture and don't recognize that age difference, we're prone to cutting out the lodgepole and the larch and leaving the grand fir and the Douglas fir. And that's precisely what's happened in much of the West. Not recognizing that they're different ages. I mean, that they're the same age, assuming that they're different ages. So without appreciating age structure, we may be unable to understand the dynamics of the system that we're managing. And I don't think we should be managing anything if we don't understand it very well. So my 5th myth, uneven age stands are more natural. Close to nature is one of those terms I showed you up front. And it's probably the original natural silviculture movement. It's not common in this country, but if you go to other parts of the world, particularly Europe, you'll hear a lot of people talk about close to nature silviculture. It and the other names that are similar are basically a reaction to abusive practices in the past. They're usually attached to single tree selection or uneven age silviculture. They're successful in Central Europe. And they primarily use what's known as the Plenter System. The Plenter System is what they call single tree selection in Central Europe, where they manage fir and beech and spruce. But the question is it natural? And probably the foremost expert in Europe is this guy. He's a friend of mine, Jean-Philippe Schutz. And he wrote that we can conclude that as a general rule, plantering, which is just the verb form of the Plenter system, is a man-made system which needs man's intervention in the form of structure intervention to maintain it in the long run. In other words, uneven age silviculture in Central Europe is not natural. It's not a natural disturbance regime, but yet it's labeled close to nature. And the reason is not anything to do with ecology. It seems to be largely because it feels good. It feels good to do something that's lighter on the land than something that isn't. There's a group called Pro Silva, and they have these principles here. I'm going to fly through those and take you down to the bottom here. Well, let's look at the second one. Find my thing here. The third one, it says selection, felling, and tending of all stages of development. In other words, they're promoting uneven-aged or selection systems. They work towards a balance. There's the B word. They only use natural regeneration. In other words, they frown on planting, and they restrict the use of exotics. And so now you have to think about Europe. And if you've been there and studied the forests, you know that they don't really have that much species diversity, particularly north of the Alps. And what that means is that they don't have many species to work with, and the effects of climate change on that region are going to be really dramatic. And if you can't plant trees, if you can't think about moving other trees in or moving them around, they're very much handcuffing themselves. And so in this attempt to call themselves natural and be more natural, even though the system isn't natural, they've really handcuffed themselves. So what's natural? Depends on the context. Europeans, when I spoke about what they view as natural, it's completely different than the way we view it. And a lot of that's because we live in this environment where we can go out and we can look at, say, the fire scars on a tree and interpret that fire history. We know that the forests maybe haven't been affected in the last 150 or 200 years, and we can see that. But they have no idea what a pre-human disturbance regime would be in those regions. So modified by humans, the perception, again, may not be rooted in ecology. It changes with time. It's changing quite a bit here in this country. And it certainly isn't natural in the manner in which uneven-age silviculture is being practiced in uneven-age in Europe, and I would say even here to a large extent. When we try to create these reverse J diameter distributions, I think we're straying from that. And so over natural landscapes, what we'll find is a high diversity of structures, including some even-age structures and some multi-age structures. And that gets to this idea of a balance of nature and how that fits in. So, sixth myth is uneven-age stands or uneven-age systems assure sustainability. And this is some work I did in Europe where I got some long-term research plots. And so if you'll notice this time scale down here, it goes all the way back to 1900. I got these permanent plots from Switzerland, or this data from permanent plots in Switzerland. And it actually went back to about 1880. And I kind of had to throw out data that was earlier than the data shown on this graph because they didn't reliably estimate heights back in those days. And you think, well, didn't they have hypsometers? No, they didn't have clinometers. They didn't have abneys. They would send somebody up a tree, a dominant tree, with a tape, and they'd get to the equivalent height of a neighboring tree that was shorter, and they'd call down and say, okay, that's the height. And that made it really unreliable to measure anything but the smaller trees in the stand. So you think about it, how far we've advanced in 100 years in terms of measuring trees, and it's probably no more so than in the way we measure heights. But what this is the basal area of these individual plots, and these were large individual plots, and you see that they were all managed with this Plenter system or this uneven-age system in Central Europe, and you see the patterns here. And what I want you to kind of visualize is that most of these are trending upward over time. Okay, a couple of them go up and down, but the general trend is up. Okay, this is the basal area increment, and you notice some choppiness here. When you talk about these time frames in Central Europe, it's hard to look at some of the effects of some of the other events that are non-forestry. But what I want to focus on here is that the trend is generally upward, particularly in the last 20 years or 15 years of these data. So what you see is increasing increment. And this is a European issue that's associated with both climate change and air pollution. Air pollution seems to have had an initial boost in terms of its effect on growth rates, and now what you're seeing is it's beginning to fall off. So a little sulfur and nitrogen were good, but a lot isn't, kind of thing. And then one more of these, and this is just the size diversity. This is the Shannon index looking at the number of size classes, and you can all see that that one is all increasing. And the point here is that they managed these stands for nearly 100 years with the exact same methodology. The people, of course, changed, but the methodology was supposedly the same. But what they found was that they were getting increasing stocking. The number of diameter classes had expanded. Increasing species diversity, I didn't show that. And so what this means is that for these long-term research plots, the best uneven age research plots in the world, the system's still evolving. And so with any adaptive management system, and with climate change as an added variable, there is no reason our management should be constant. And what's really ironic is that this is the diameter distributions that they use to guide some of their uneven age stands. And so what you have is the solid line is a beech curve, and the other line, the dashed line, is a fir spruce curve. These are the curves that they model to. So one of the interesting things about uneven age silviculture in North America is that we look at this reverse J-shaped diameter distribution, and we focus on it like it's the Holy Grail, and we say things like, well, it's from Europe, that's the way they do it. But it's not. They've moved on. They've moved on to these other distributions that actually favor larger trees. There's more room for larger trees with this type of a distribution. 7, uneven age stands are only suitable for shade-tolerant species. I'm going to go through this one pretty quick. Mixtures of shade-tolerant and intolerant species work in even age stands. And what I've done here with my colors is I've got warm colors for shade intolerance. Let me go back. And cold colors for your shade-tolerant species. So just to whip through this, you can grow intolerance in uneven age stands. They get enough light down here to grow beneath other intolerance. You can do the same thing with tolerant species. They get enough light in the understory to grow. You can put a shade-tolerant species under an intolerant. You can put Douglas fir under western larch or ponderosa pine. But you cannot do it the other way around. You cannot put that western larch underneath the Douglas fir or the grand fir. There's not enough light. And so this doesn't mean that we can't grow uneven age stands with shade-intolerant species. I mean, this is one of the classic places in the whole wide world to do that with ponderosa pine. So it can work. That's a myth. A picture here, this is from Finland, and what you see is a Scots pine stand. You recognize Scots pine from this orange bark that doesn't go to the ground. And in the middle there, you see a Norway spruce. And notice that the Scots pine crowns, you can't even really see the bottom. They're up pretty high. But the Norway spruce crown goes all the way to the ground. And it's a classic example of a shade-tolerant species with foliage all the way to the ground because there's enough light left over from the intolerant Scots pine to keep it alive down there. 8. The Central European model for selection silviculture is appropriate for other systems. And I've got a plaque that's out in the woods, homage to Henry Biolay, Silviculture 1858 to 1939, one of the pioneers of the Plenter System in Switzerland. And the system primarily consists of these 3 species. And what's notable about these 3 species is they're all shade tolerant. And this is an extremely forgiving system because you can manage, you can take out a few trees, and because they're tolerant, they'll come back. It's extremely forgiving. It's like nothing else that we have in this country except maybe northern hardwoods. My 9th myth, uneven age stands are less productive. This is some of the work that we started when we were here in Montana. And what I've got here is the leaf area index of even-aged and multi-aged stands in Montana. This is around here. We also did this in Oregon. We also did this in South Dakota. And what you see is that the even-aged stands typically had a little bit more leaf area, but not any more in a statistically significant way. This is the increment and over here on the left. And so there's the even-aged and the uneven-aged. And you notice that in 2 of the 3 study areas, we had greater increment in the multi-aged. These are the same stands that I just gave you the leaf area from. And what that means then, if you go over here to the right, is that if we divide the volume increment by the leaf area and look at the efficiency of these trees, we start to see that the multi-aged stands are more efficient with less leaf area than the even-age stands, implying that not only is there not a productivity disadvantage, but maybe there's an advantage there. They're at least even. And This is some of the work that we did. You see this dates back to 95 and 96. We looked at the water potential. This is in negative megapascals here, so the scale goes downward. And we measured trees in even-age stands and multi-age stands in June. You see they're about even. In July, we start to see a difference here. And in August, a greater difference. And what this means is that the even-aged trees were more water-stressed than the multi-age trees when you get to those mid-summer months. And then the effect starts to decline in September. And so that's the first year. We were kind of surprised by that, and we said, well, maybe that was just a fluke. We went back the second year, and the results were even more dramatic. We had greater productivity in the multi-age stands again, or less water stress in the multi-age stands again. So that's the mechanism that we thought existed for that. So my last myth here is that multi-age stand productivity is unaffected by density and structure. And this is just a diagram of stand structure where these bars show the crown length and the length of the bowl beneath the live crown. So in an even age stand, you see that the crowns are all pretty much at the same level in a single stratum. And in the uneven age stand, it's much more complex down here at the bottom. This is the growth of trees in different crown classes in an even age stand. And so what you see is that the dominant trees are kicking butt and the suppressed trees hardly growing at all. No surprise there. But when we go to an uneven age stand, and here's an uneven age Ponderosa pine stand, and that's the kind of data that I've got here. Here's the oldest cohort, and we see the same kind of thing. It's growing much faster than the second oldest cohort, which is growing much faster than the third oldest cohort. And then when we get down to the bottom of the canopy again, whether we're talking about even age stands or uneven age stands, the trees aren't growing very much at all. And what that means is that during the progression of stand development, we have an individual tree, say maybe that one, and it grows up. And as it moves up in this canopy and older trees are removed or die, the growth rate increases over time. And so when you look at this, and if your only objective were to maximize productivity, you'd say, well, why don't you just grow these trees? They're growing so fast. But if you're going to have a multi-age stand, you can't have only big trees that are growing fast. You have to have some trees to replace them. But the question is how many do you need? It goes back to that reverse J-shaped diameter distribution in my first myth. Do you really need to have many, many small trees that aren't growing very fast to replace a few big trees later on? And I would argue that you don't. And one of the things that we did was we developed this model and a model to predict volume increment where we kept leaf area constant. And we just arranged the numbers of trees in the stand to be in these different positions in the canopy. And what we found was that the more trees you put up in the upper canopy, but keeping enough replacement trees to eventually replace them, you get the best productivity. And where you get the worst productivity is when you follow that reverse J diameter distribution and put all of your growing space or much of your growing space in for smaller trees. So not only are we recommending that there's another way of managing the stand, but it's a way of managing the stand that can enhance productivity, at least for Ponderosa pine. So what's the most appropriate diameter distribution? I've got a reverse J curve, the rotated sigmoid curve. I've got a nice straight arithmetic curve. I'd say probably none of the above. I don't think we need diameter distributions. I think that we can simplify structures to a few age classes. We can look at longer cutting cycles, longer periods between cutting, and that for many western forests, these structures are closer to what we would be found under a normal disturbance regime. In other words, I think we can make more natural structures, simplify things, enhance productivity, and throw out this idea that we need to hit a particular diameter distribution. Diameter distributions don't meet management objectives. So, going forward here, silviculture is traditionally defined as an art and a science, but where's the art? Maybe 20 or 25 years ago, we started talking about this thing called quantitative silviculture. Some of us have colleagues that label themselves that way. I'm not really quite sure exactly what it means, but it's primarily been focused on even-age silviculture. It integrates density management with growth and yield tools. And what you see here is a density management diagram. And it's kind of like a race to put more lines on a graph. That's all I'll say. It's primarily focused on timber. It promotes uniformity across stands because it tends to prescribe a particular density management zone and encourages you to keep stands within that. It provided for repeatability. And that's the theme in my last few slides, that what we really want in stands traditionally, or at least as we move forward with forestry, is the ability for me to go out and do something and then say, Justin, go out with the exact same prescription and create something that's similar out there. Another repeatability is also important in science. You know, that we throw out a particular idea and we test it, and that we can have different people get the same results. So, and then it ignores the unique structural features that may be unique and highly desirable in a stand. And what I mean by that is that here's a Ponderosa pine stand. We've got a lot of large trees in there. And darn it, I don't know very many objectives that don't really demand for more large trees. But yet, many of the density management tools that we work with would say we need fewer of those to make it fit a particular design. So, these are 3 books that have been published in the United States. This top one is a Forest Service document that discusses a forest in the Missouri Ozarks. You see half a century. This is a book that was published by John Mount, who's in California. He works for Southern Cal Edison as a manager of a forest. And then we have this book here about managing longleaf pine mostly in Georgia, but in the southeastern United States. All 3 of these examples are ways to manage uneven age stands without these highly quantitative tools. In other words, it's managers that went out and figured out how to do it and were able to, at least in some cases, pass it along to their coworkers and create a system for managing uneven age stands that's based more on art than science. It's kind of a step backwards in a way. Russ Graham was one of your seminar speakers in this series earlier this semester, and he published this paper in 2005, and you see the word free selection there. And he basically talked about a well-articulated vision of what the stand should be, and focusing on that in terms of marking and layout. This is one of my colleagues in Slovenia, Andre Boncina, and he talked about freestyle silviculture. And he said by using this system, consideration for site conditions and heterogeneous stand dynamics at small spatial scales is possible. In other words, if you have some large pumpkin Ponderosa pine trees, you should be able to find a way to integrate them into the prescription. So, a paradox is a statement or concept that contains conflicting ideas. So the question is, how do we free silviculture? I love that term, free silviculture, to create heterogeneous, complex, or resilient stand structures while also providing for consistency in space and time? Or how do we reintegrate the art of silviculture without losing our scientific credibility? And this is a system that we developed here, and it's called the Massa model. I'll go through that in a second. But what you see here is trees per acre and age going from youngest to oldest. This is analogous to that diameter distribution that we've been talking about. But rather than being reverse J, it's kind of arithmetic, and then it jumps upward. This is a system to manage Ponderosa pine in sort of a pre-settlement type structure. Large, big trees with some replacement trees coming up underneath. Okay? Does not fit anything that's out there in terms of management guides. But yet, these are really valuable resources. Here's the spreadsheet that we'd use, and I'm going to skip over that just to say that we've developed this thing, and it's out there, and it's usable. It's called the Multi-Age Stand Assessment Model. It's not so much a guide as it is something that allows you to assess different options. It uses leaf area index to represent growing space. It's flexible to a wide range of stand conditions, and it allows for consideration, and this is from that Boncina paper that I quoted, allows for consideration of site conditions and heterogeneous stand dynamics at small spatial scales. It's just an example of a system, though. So, silviculture and society in the USA, foresters are not highly respected. But society needs clear and consistent descriptions of stand management outcomes. So part of the problem in terms of credibility is communicating what we think we can do in a forest and convincing them that it's the right thing to do. Simply saying that evolving approaches to uneven age silviculture or foresters expressing their inner artistic talents will not be acceptable. In other words, the art's really a great thing to talk about, but it only works to a certain extent. Is repeatability important? The implementation of treatments is not science, it's management. And if it's art, then we really don't want it to be repeatable, right? Right? How many Mona Lisas do you really need? So, Silviculture Unchained. This is my second to the last slide. There is a paradox, and it's and the paradox is that it's difficult to manage for complexity, to create heterogeneous stand structures out there in a systematic way. It's not even human nature. Free silviculture, flexible systems that accommodate existing structural features and site conditions. I think that's the direction that we ought to go in. And I'm not saying let's abandon quantitative silviculture or even age management. I'm just saying that for many places, the management that we need to do in multi-age stands needs more flexibility. And we need to work towards applying more flexible stand management to achieve landscape level complexity. And so how do we add the art back into silviculture in such a way to ensure that it's repeatable and consistent? And then my last slide. Thank you very much. So my students, let me just explain here. My students, I believe, keeping confined into a hollow of a redwood tree. But silviculture should be unchained. It should be free. So thank you.
We'll be able to take some questions.
I'll just make a comment that my experience for 25 years on the Lolo is we've been practicing unchained free silviculture for a long time. And in fact, in today's paper was an article about Rennick Stark, which was litigated, but is the second entry into Stark Forest was in the mid-90s after Dr. Stephen Arno's fire history and ecology. We have started moving our Ponderosa pine stands into an uneven age system.
Yeah.
I just want to put that plug in, Kevin. Thank you. 25 years ago, we've been doing it.
Yeah, that's great to hear.
The other comment is you have a lot more flexibility on tractorgram than on skyline cablegram.
Yeah, operational constraints are often overriding.
Kevin, that's a very interesting presentation. If you go to the last slide before this, it speaks to that using stand level management to get at landscape level complexity. And certainly that's counter to the European direction of smaller and smaller scale management, but not a whole lot different than what Meyer had been characterizing at a larger scale in coming up with this sort of a balance. So I'm just curious about your perspectives on how we might manage into the future with this art by focusing on repeatability at a larger scale rather than repeatability at the stand scale.
Yeah. Well, I think it's different than what Meyer was talking about, and that his was essentially it was essentially a homogenization. It was take the average of the whole county and make every stand look like that, which was no variation at all. And so I think that by looking at individual stands and recognizing that each one of those may have operational constraints, it may have site differences, it may have a different disturbance history, and sending somebody out there with broad guidelines that allow them to do a lot of different things. And so that if you and I went out to the same stand, we'd come up with the same thing. But it would be different than what we would come up with in the stand next door that may have had the same management objective, but just because there were differences there. And I think that's how you achieve that landscape level complexity. It's giving the people the freedom to do individual things at stands, not just one. So.
I have a question.
Yeah.
You did kind of answer most of my questions, unfortunately, but or fortunately. But can you speak a little bit more about the fire tolerance of uneven age stands compared to maybe a big open even age fire tolerance stand?
Well, so if you couldn't hear the question, it was about the relative fire tolerance of uneven age stands or multi-age stands versus simpler structures. And that's a classic. I don't put that as a myth, but it's been a classic black eye for uneven age stands traditionally, and that they're viewed as having a greater danger of having fire. And the reason for that is the fire ladder potential. And that exists primarily if you follow this traditional model. If you have all sizes present, you're probably going to have a stand with high stocking and a nice string of crowns going from the ground to the top. And what I advocate is let's open it up. Let's keep the stocking low. We recognize that for even age stands. Let's have fewer age classes so that we do have some trees that are small at certain times, but they don't necessarily form ladders to upper canopy layers. And then I often, when people start advocating even age silviculture with that argument to me, I also remind them that even age stand is going to be very vulnerable to fire, even with a fire-resistant species like, say, Ponderosa pine or western larch, when it's young, when the crowns are down near the ground and the bark's thin. Both structures have their vulnerabilities.
Any other questions?
The quantitative tools that you described up there are useful for young foresters that don't have experience that will help them be free. So they're decision support tools that help people make decisions, especially useful for young people. So if they don't have that, then then what's the method that they acquired their expertise over time, aside by trial and error? And then even for experienced people, they can sort of justify their treatments on the basis of some kind of quantitative or some kind of background pattern, and that provides the appearance that the treatment is not arbitrary, or the mark is not completely arbitrary. Get back to the repeatability standpoint. So can you address that? How would free silviculture work for those two groups?
What I'd like to be seen as advocating is a free silviculture that includes both, that includes some quantitative tools, but that guide treatments on a general basis, maybe on a forest or a landscape basis, but that give the forester the stand level freedom to do more, to be more creative. And I don't think those are incompatible. And so I'm not saying let's throw out the density management tools. I agree with you. They're really important for learning. I think they're really useful for even age stand management, but I haven't really seen anything for uneven age stands that really do that. And the reason I showed you guys that massive model where we allocate leaf area to different age classes is because I think that's a way of doing that. It's a way of, it's a tool that allows a young forester or an old forester to lay out an option and see what the implications are of that, and then maybe change it on the computer before they go out in the woods with the marking gun. So that's the way I see it.
When you think about, Kevin, the differences in perspectives in Europe versus the United States, I'm curious whether you see a divergence of ideas in how multi-age management will be used in Europe versus the United States.
I don't know if I see a divergence between here and there, but I see a divergence in Europe between a group of people that are very traditional and that view this as natural, and a group of people that I see as more realists that are recognizing that they've got lots of things going on. They've got climate change. They can already see a increased disturbance frequency and intensity on their forests. They're recognizing that the most adapted species to the climate right now in Germany or France may not be Norway spruce or European beech. It may be Douglas fir. And yet, a lot of people would say, we don't want invasives like Douglas fir in our forest, you know, putting on that bad label on it. So I think the party that I describe as the realist party is really more similar to what you'd see here. So I see it, I'm biased, but I see it as more scientific based and less traditional, and then I'll also say less old fashioned. It's recognizing that they had a really resilient system there to do that in, but that system is changing really fast because of climate change.
Well, I think that about wraps us up for now. If you have any other questions for Dr. O'Hara, you feel free to come on up and ask him. And thanks again for attending the final fall seminar series of CFC. And have a good evening.
Thanks. So,